Good morning and welcome to another repairs video in Space Alvestech. In this video we're going to see one more. In this case it's about of a hot air gun, a generic hot air. Okay, they are already coming. Thus in this generic way there are now some. In this case they only bring the motor. Just bring the part of the resistors and the wiring to connect the circuit components elements. Okay, this is a type of heat gun. In this case, this is a very generic brand, and this is an example of that type of hot air gun. In this way, very cheap. So the flaw in this gun, it was the motor, right? Then the motor after a while later, because the motor is connected in series with some resistors, heaters that go here, then that motor is subjected to a lot of current because it's just the motor, a rectifier bridge. The same bridge goes behind in this place of the motor, and that's all, right? The AC circuit enters directly, and it goes to a resistance, and the resistor is in series with the motor and acts as. In this case, it would be, the circuit limitation would be the same heating element in this case. So the fault, why was the motor the problem? I already changed this one. This isn't. This was the motor. I already knew it. I changed it, okay? The problem was that it presented sizzling in the part of the collector, a very sizzle, evident in the area where find the brushes. They make contact with the collector. Then when that sizzle is a huge exaggeration, it is an indicator of that the rotor armature windings, they are exhibiting coils short-circuited between them. Okay, so that's the problem. That's an indicator that the motor is in bad condition, and another thing, which is very evident, is that it no longer rotates the same speed. The motor revolutions decrease considerably then. That is also an indication of the motor is broken, and the repair is very simple. Simply replace it with one in good condition and of the same characteristics. In this case I have get this even. They are of same size. I think it's not exactly the same motor. So here comes the little one advice. Let's say the adaptation we can make. And I'm going to show you in this video. Like here, what's going on? The motor, since it is not the same, it's not exactly the same, and this can be seen, for example, when connecting it to the circuit gives many more revolutions than that's. If we leave it thus, what will happen? It won't last long then. It's going to burn very quickly. To avoid that, in the part of circuit that powers the motor, I have modified by capacitors, serially connected, one capacitor for each speed. That is to say, the motor do not be directly connected to the 120 volt of AC from the network, but rather that it passes through a capacitor in series with the motor. This value worked for me. A pretty good is one of 4.5 microfarads at 120 or 220 volt of AC, and the other one is 7 microfarads to the same voltage. This circuit is called capacitive source, and it is you already know, it is being used a lot in many products, especially that come from China currently, because it's a very simple circuit and very low cost, very cheap. So in Chinese products, they are coming with these power sources, but in this case, it wasn't coming with this capacitive source. I put it on myself because the original circuit comes with a resistor of the same heating element, has a branch taken out to connect the motor. But what happens? That circuit presents a drawback that I'll explain it to you in a moment. Let's do it. And here it is. The circuit as it comes. This is a crude diagram. To put it mildly, and it's nothing. It's simply nothing. No. That's how it comes. Right. It comes one phase, and the other two ends of that kind of spiral made of nicrom with this form, which this wire represents is the nicrom wire right. And of a central part they take a branch with a diode, and that's what it does. It cuts back half a wave. So what they achieve with this is that the resistance drops to half of power. In this case, the resistance meter will be reduced when the current passes through this diode halfway of its power, and when it goes directly through this conductor, then it will be the full power. Then they achieve in this way. With this switch they deliver. They perform the function of maximum max power, and they give us a secondary minimum function. Okay, then they simply do that with a diode. In this case, what is missing? For the motor, they simply take a wire from the same branch of the motor again and connect a cable, a conductor, to one end of the motor, and the other end is connected to the another phase. And that's all, folks. We have obtained the voltage for the motor. Similarly to the previous case, when the circuit passes through this diode, the motor will also decrease speed. And when the current passes directly, then it goes to spin at maximum revolutions. Okay, but what's going on? What happens, for example, in this case, when the motor has burned out, and which is very possible. It has been, because in this part of the circuit, like this, remains directly connected. Consequently, there is no regulation of temperature. Then is very possible that the nicrom wire at some point it will open the circuit. So it happens whether it open the circuit, for example, in a part. If the circuit opens in a part, let's say here in this part, so what's going to happen? The current that was coming from this side towards here and this way, it's not going to pass now. Assuming this is opens here, the current that was going along here, no more current will flow through here, but that the current will only pass through this part. So all the current that before did crossing here, all going to pass through here now, which will cause the motor recharges, overload, and burn. This is another example of that phenomenon, that situation in which I am assuming that opens the nicrom filament. It's the same as when we have a motor in a circuit like this, where the adjustment, let's say that the voltage adjustment has been made and the current adjustment has been made simply by using a voltage divider made with two resistors. Then, of course, here we can't connect the motor directly to the source, so we make a divisor. But what's happening, assuming here that we have this direct current in continuous DC, if we have a motor with the voltage divider, right? So here we're going to have a different voltage. A voltage, let's call it V2, and here we have V1. Okay, so it's up. Well then, under normal conditions, the circuit is connected here to the motor But let's suppose that a fault occurs here, and it opens. This resistance, right, then is opened. And what happens now? That now the voltage that is now present in the motor isn't going to be V2, right? Because the current no longer goes through this resistance. And the voltage divider is disabled. It is automatically cancelled when this resistor opens. Therefore, the voltage no longer, it's going to be V2 at this point, but it's going to be. Which one will it be? It's going to be V1. So from V2 to V1, there's a big difference in this case. Assuming the motor, whether an 18 volts motor, but instead of 18 volts here are going to be 120 volts under such assumption. So the result is that it instantly goes to burn out the motor. So that situation that arises with this circuit, which includes this air heat pistol. When a part of the divisor is cancelled, all the entire motor voltage will be connected to AC line voltage. Therefore, all the current in the motor takes it away and it burns immediately. So that's the disadvantage I've seen to this type of circuit. Therefore, we have proposed from this YouTube channel an alternative circuit, an improvement, let's say an alternative design, which will consist of replacing the motor's power supply per a source, capacitive. So here I have the circuit. It involves connecting the motor separately. This doesn't belong here, related to the heating element with the wire of nicrom, but this will go apart. The circuit of the heating system will remain unaffected. It remains the same except that the motor goes to be connected by means of two AC capacitors, one for each speed. For example, in this case, I used one of 7 microfarads and another of 4 microfarads for the lowest speed, and the 7 microfarads one. It's for maximum revolutions, or what would be maximum power heat, then. That would be it, right? 7 or 8 microfarads. And what is achieved by this? It is achieved that the motor is not connected directly to the line in case of a failure, or in case of a failure of from nicrom wire, because if one of these capacitors fails, likewise it's going to burn anyway. However, it is achieved to have it apart from the nicrom wire. In this way, the motor is powered supply by means of it called a capacitive source. Everything else is the same. So we feed the motor with capacitors connected one on each side of the switch, one for the first gear low speed and the second capacitor in the another switch pin of the second gear high speed. This is what the modification consists of that has been done to this pistol of heat air. Oh, I forgot to mention that. I almost forgot to mention that the capacitor, it's not connected directly to the motor, but before there is a rectifier bridge of diodes, the typical one, N4007. On the circuit it would be. In this part, I mean it doesn't go directly to the motor, but that here there is a rectifier bridge. And afterwards of that bridge, there goes a wire to the positive motor terminal. and the remaining cable to the negative. So, in this way it is, and here are a couple of capacitors, tiny, lentil-type ceramic. And the same would apply to this part. A diode bridge would go here, and this cable would go here to the motor on the positive terminal. The remaining motor cable would go to the negative terminal of the motor, and this bridge entry would go to the AC line. Okay, I think the general idea is clear. I have taken advantage of this space in this part from the back to place the capacitors, taking care that they don't. Making a short circuit is just that, the circuit. I'm going to put it on my website members blog. All the detailed information is here. The schematic, the circuit diagram, and everything very well explained. Okay, this is how the circuit looks. The modification for the motor circuit has been completed. For this air hot gun, a generic brand hot air pistol, I suppose it's from China. Very well, alternative technical enthusiasts from the internet, it's all about remembering the dangers and cautions to always take when working with electricity. Give me a like and subscribe. If you found this content helpful, please let us know in comments. Here's or in description my playlists of videos about repairs, and as always, see you soon in an upcoming video. Bye.
Y vamos con las menciones de miembros.
Llegó lo que tú querías. En este espacio de Alvite, proponiendo alternativas. En este espacio de Alvite.